Hello math fans, welcome to another exciting edition of Geometry at Home. This week we're looking at parallelograms, okay, and parallelograms have a lot of interesting properties, especially when you talk about the more specific types of parallelograms. You get into rectangles and rhombi and squares, and all kinds of fun stuff happens when you look at the special properties, special parts of those figures as well. Now, this is basically what your assignment looks like. And I'm going to do a few of these for you, show you how to get through a couple of them. Okay, but before we get to that, I want to look at the notes that should have been posted in your class notebook. Okay, so if you go into your class notebook, you'll see two different pages of notes. One is titled Parallelograms. The other one is Parallelograms Proof by Triangles. So this is the proof by triangles. So what we have here on this one is a whole bunch of triangles that are pushed together to form special types of parallelograms. So if I take two acute scalene triangles, okay, so all three angles on this triangle are less than 90 degrees, and all three sides on this triangle are different. Okay, but these two separate triangles are the same. You know, if I put these two triangles together, no matter which side I squish together, the double tick, the single tick, or the triple tick, if I put those sides together, I end up with a parallelogram of these. And when we look at these two congruent triangles, we notice that this angle and this angle are congruent, this angle and this angle are congruent, this angle with the O and this angle with the O are congruent. Now we recognize that this happens on all three of these pairs. Okay, so what that tells us is some special stuff about the angles of this parallelogram, the interior angles. Now we can also notice that this side has a single tick, this side has a single tick. That means that these two sides are congruent. This side has a triple tick, this side has a triple tick. That means that these two sides are going to be congruent. Now guys, if we start to look at those properties on all of these different pairings of triangles, we're going to start to recognize some special properties with these parallelograms. Now, I'm not going to go through every single one of these explanations right now. I think this page, these couple of pages here, do a really good job of explaining how this works. Okay, what you really want to focus on when you look at these, each one of these pairs, is you're taking two, or on some of them four, identical triangles. So this triangle and this triangle are congruent. They're exact same triangle, just one is rotated. Now, if we do this, we can recognize some special properties dealing with parts of the quadrilaterals that are formed. So pay close attention to what's on these couple of pages, okay? And it really explains why these things have to be true. But here's the short version, okay, right here. If you know a shape is a parallelogram, by definition, a parallelogram is a quadrilateral with opposite sides parallel. Now, if you have that, you also end up opposite sides parallel, opposite sides congruent, opposite angles congruent. Consecutive angles are summed to 180 degrees, which means they're supplementary, and we end up with these diagonals bisecting one another. Okay. Now, if we have a rectangle has these two sides parallel and these two sides parallel, which makes it a parallelogram. So all of these properties that are true for parallelogram are also going to be true for a rectangle. So we get all six of these properties for a rectangle. We also know that the diagonals of a rectangle are congruent to one another. And we also know that all four angles of the rectangle are congruent because, well, they're 90 degrees. And this right here, ladies and gentlemen, is the definition of a rectangle. A quadrilateral with four right angles. Rectangle, right angle. Not just a clever name. Then we come over here to a rhombus. Okay, now a rhombus, by definition, is a quadrilateral with four congruent sides. That's it. That's the full definition. Now, because of those four congruent sides, it turns out that these opposite sides have to be parallel. And if opposite sides are parallel, that makes it a parallelogram. A rhombus also gets all six properties of a parallelogram, plus its diagonals end up being perpendicular. Okay, and its diagonals bisect one another. Excuse me, they bisect the angles. They are angle bisectors. Okay, now we got one more special quadrilateral to look at here, and that's a square. Now a square is by definition quadrilateral with four congruent sides. Hey, if it has four congruent sides, that makes it a rhombus. It also has four right angles, and if it's a quadrilateral with four right angles, that makes it a rectangle. So a square is where a rectangle and a rhombus overlap. Now, that means that it's also a parallelogram. So that means all of these properties listed up here, every single one of them that was true for a parallelogram, rectangle, and rhombus, all of those are going to be true for every single square. So here's a handy little chart that gives you all the properties for each one of those figures. Okay, this a little bit smaller so you can see the whole thing. There we go. Okay, so this is kind of your shortcut right here. Okay, any property you want to know which one of these figures has that property, just check out the checklist. And like I said, this is on that notes page inside your class notebook. All right, now let's get to the meat of the matter. Okay, let's take a look at your worksheet here. So what I'm going to do is just one or two from each of these sections. So number one, we want to determine whether the statement is always, sometimes, or never true. So let's go with C. A parallelogram is a rhombus. Okay, so they want to say that every parallelogram is a rhombus. Well, a parallelogram has opposite sides parallel, and that's true. Okay, now that's definitely true for a rhombus. A rhombus has opposite sides parallel. But the special characteristic of a rhombus, okay, is that a rhombus has to have not just opposite sides parallel, but it has to have 4 congruent sides. That's what makes a rhombus a rhombus. Parallelogram doesn't necessarily have to have that situation, doesn't have to have all 4 sides congruent. A rhombus does. So, a parallelogram can be a rhombus, but it doesn't always have to be. So that is going to be sometimes true. Okay, I'll tell you what, let's look at another one here. Let's look at B. The diagonals of a parallelogram are perpendicular. Okay, well, let's go back to this page and let's see what we have. Diagonals, diagonals, diagonals are perpendicular. Diagonals are perpendicular for a rhombus and a square. Well, a rhombus and a square are both special types. Are both special types of parallelograms, but they are not every parallelogram. So once again, this is another situation where it is sometimes true, but not always. Okay? All right. Moving on. Number 2, quadrilateral ABCD is a parallelogram. So I know this figure is a parallelogram. I don't know if it's a rhombus, rectangle, square, anything but a parallelogram. Okay, in part A, they tell us that the measure of angle BAC is 54 degrees. So angle BAC is 54 degrees. Nope, that's not it. Sorry, BAC is going to be 54 degrees. Okay, so that's this guy. Now, they want to know about angle DCA. Okay, that's this guy. Well, one thing we know about parallelogram is that the opposite sides are parallel. So this side and this side are parallel, and this is the other line that forms both of these angles. Well, if that's the case, if that's true, I've got a pair of parallel lines and a transversal. And the two angles that they're describing, the two angles we have highlighted, those are alternate interior angles. And we know that on parallel lines, alternate interior angles have to be congruent. So we can say, if we know that the measure of angle BAC is 54 degrees, that means the measure of angle DCA must also be 54 degrees. Okay? Let's come down here to part F. Okay, now it's still a parallelogram. In part F, we say that EC, okay, that's this section, is 10 centimeters, and EB is 15 centimeters. They want us to find the length of segment AC. Okay, that's this whole piece here. Well, this whole EB being 15 centimeters, that's kind of extra information. It doesn't really help me right here. Okay, I'm talking about the diagonals of a parallelogram. And if we go back and we look at in the parallelogram column, in these ones, okay, anything about the diagonals? Well, I have the diagonals bisect each other. Okay, and that's true for a parallelogram. Now, if the diagonals bisect each other, and I go ahead and look at this diagram, if EC is 10, that means that AC must also be 10. Okay, these two are congruent. Excuse me, if EC is 10, that means AE must be 10. So if they have each of these are congruent to one another, and they're each 10, that means that the length of the whole segment has to be 20 centimeters. Okay, I'll tell you what, let's come down here and let's take a look at on number 4. On number 4, they tell us that this quadrilateral ABCD is a rectangle. Okay, let's look at part F here. Okay, part F says that AD is 6, BC is 8. They want us to find the length of segment AE. Okay, just this part. Well, if I look at what they've given us, and we pay really close attention, they've given us this piece, and they want us to find this piece. If I extend that, guys, I've got myself a right triangle. Okay, so I can use 6 and 8 to find the length of this whole side. So that's exactly what I'm going to do here. Okay, so to find the length of that whole side, I know a squared plus b squared has to equal c squared. So 6 squared plus 8 squared equals c squared. 6 squared is 36. 8 squared is 64. And if I add those together, that's 100. Okay, now I want just c. This is c squared. So that means I have to take the square root of that 100, and I get that the length of the whole side, AC, is going to be 10. Okay, but they don't want AC, they don't want the whole thing. They just want AE. Well, I know that on a rectangle, these diagonals are going to bisect one another, which means that AE is going to be half of AC. So that means that AE is going to be 5 centimeters. Okay? All right, tell you what, let's take a look down here at part number 5. Let's look at part C. Okay? They tell us that this is a rhombus. And we have x is right here inside this angle. And they give us that this angle is 28 degrees. Okay, now, we know that opposite angles in a rhombus are going to be congruent. So that means that this whole angle here and this whole angle here are both going to be congruent. Now, we also know that the diagonals of a rhombus bisect one another. So that means that this line bisects both of those highlighted pink angles. Okay, well, we talked about this much earlier when we were working on proofs with triangles. If you have two congruent angles and you bisect both of them, those smaller bisected pieces are going to be congruent as well. So that means that 3x minus 5 has to equal 28. And then we just solve for x. So we add 5 to both sides, and 3x equals 33. Divide both sides by 3, and we get x equals 11. And there we go. Okay, now let's take a look at one more, because I think that's the last ones that are on your worksheet. Okay, all the way down here on number 10, we're given rectangle ABCD and the given information to solve each problem. So what we're going to end up coming back to a whole bunch here, guys, is this page with all the properties. Okay, this is pretty much going to be everything that we need to know about what properties we can use to answer these questions. Now this time we're talking about the rectangle stuff. So all of these things are going to be true for us. We know that the diagonals are congruent, they bisect each other, all 4 angles are 90 degrees, consecutive angles are supplementary, opposite angles are congruent, opposite sides are congruent, and opposite sides are parallel. Okay, those are all the things that we're going to have for this question. So let's take a look at them. Let's take a look at B. They tell us that AC, that's the whole diagonal, is 4x minus 60, and AE, that's only half of that diagonal, is x plus 5. They want us to find x and the length of EC. Okay, well, like we said, this is the entire diagonal right here, okay, and it is 4x minus 60. Now, I know that the diagonals bisect each other, so that means that this segment, AE, is half of the whole thing. So I can look at this one of two ways. Okay, I can either say that AC divided by 2 equals x plus 5, or I think something we'd be a whole lot more comfortable with would be to say that 2 times the quantity, x plus 5, double it, is equal to 4x minus 60. Okay, we can solve this equation. Distribute the 2, we get 2x plus 10 equals 4x minus 60. Move all of our x's to one side, we get 10x equals 2x minus 60. Let's excuse me, that's just 10 equals 2x minus 60. Okay, so add 60 to both sides, and 70 equals 2x. Divide both sides by 2, and 35 equals x. Now we also want to find the length of segment EC. Okay, well, segment EC is this other half. Okay, it's half of the whole thing. Okay, well, what we can do, we know that this DB bisects segment AC, so that means that AE has to be congruent to segment EC. So I can just take this 35, let's have it right here, okay, and EC will be equal to 35 plus 5, which would be 40. Okay, so guys, this whole section deals a lot with the properties. Pretty much what you're going to keep coming back to this page. Keep referring to it. On each question, just come back and look at this one, see which properties are applying, which ones you're talking about. Are you talking about diagonals? Are you talking about angles? Which one of those quadrilaterals are you working with? And then just go from there. Build the right equation, solve it. Okay? Take your time, guys. If you have questions, email me, use the chat feature in Teams. One way or another, make sure you get your questions answered. Look forward to hearing from you. Take care.